Hello class, today we're going to talk about transformational geometry, part 4. Again, we're talking about what is it and what do we need to know about it. In part 4, we're going to talk about rotations. This is one of the toughest ones we have. So let's review the definition. A rotation is nothing but a turn around a fixed point. Okay, so the two things that we're looking for right now is congruency and orientation. So in this particular rotation, we look at this original figure, and again, when it turns down, it will have no impact on congruency. Okay, but if you look at this point right here, it's top left on the figure, on the original shape, and it's bottom right on the new shape. So it does have an impact on orientation. But what we have to look at in 8th grade is how is that figure affected on a coordinate grid. So here we have a triangle. And what we want to try to do is we want to make it rotate 90 degrees counterclockwise. Now in this particular one, we are looking at counterclockwise because our default when we do a rotation is always going to be counterclockwise, to the left. Okay, and the reason why we do that is because that is the order in which we do our quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we'll rotate counterclockwise. So what I'm going to do is I'm going to make this particular shape rotate. But before we do that, we need to pay attention to what's happening to the coordinates. So I'm going to focus on this coordinate right here. Right? And this coordinate, when we look at that one, it is 1, 2. So now I'm going to perform a transformation of a 90-degree rotation. So to do that, we've got this cool little tool, okay, called a rotation tool, and it will rotate about a fixed point. Okay, so hopefully this will work. So I'm going to take that shape right there and I'm going to rotate it. So I'm going to select what it is I want to rotate. And I'm now going to rotate it 90 degrees counterclockwise. Okay, so pay attention to that point that we're looking at. And it rotates to right there. There's 90 degrees counterclockwise. So what we want to do, our original point was at 1, 2. But now where did that point go? That point went to -2, 1. So when we're looking at the algebraic representation of that, of a 90-degree counterclockwise turn, okay, our original x and y, what happens to them? Well, you'll notice the x and y do change places. Okay, so they rotate places, and my y value turned to a negative. Okay, so that happens anytime we do a rotation of 90 degrees counterclockwise. My x and my y will trade places, and my y value will go to its opposite. And you need to remember that this x and y here does not refer to a positive x and a positive y, but just whatever the original coordinates are. Okay, so that's a 90-degree rotation counterclockwise. So let's look at a 180-degree counterclockwise turn. So again, we want to focus on a single point. We're going to focus on that one right there. Okay, I'm going to put my rotation tool right here in the center again because we're rotating about the origin. We're going to try to figure out, okay, if I do a 180-degree turn counterclockwise, what will happen to my coordinates? So again, when we look at this point, the original point is at 1, 2. So now let's rotate 180 degrees. Okay, so we take this and we rotate. Well, there's 90 degrees. And there is 180 degrees. Okay, so what is our new point? Well, our original point started here. Our new point's down here. So what is that point? At -1, -2. Okay, so in this one, when we look at the algebraic representation for a 180-degree counterclockwise turn, and this would be 180 degrees clockwise turn as well, we take our original coordinates of 1 and 2. And then what happened to them? Well, they stayed in the same place. I still have the 1 in its spot and the 2 in its spot, but they both turn to their opposite. So we end up with a -x, -y. Okay, now again, remember, this x and y is referring to the original coordinate, and this is what happens to them. They're going to be the opposite. Okay, let's do one more rotation, and that will be a 270 degree. Okay, so we'll again fix a point. So this is the point I'm looking for. I'm going to place my rotation tool on the origin because that's what I'm rotating. I'm going to select the device I want to rotate. And now we're going to do 270, which is 3 quadrants. So there's 1, there's 2, and there is 3. So this one is a 270-degree rotation. Okay, so our original point again was 1, 2. But what happened to this one? What is my new point when I do a 270-degree rotation? It is 2, -1. Okay, so on this one, when we look at the algebraic representation of a 270-degree counterclockwise or a 90 degrees clockwise, our x and our y will trade places again, but this time, which one changes to its opposite? The x changes. Okay, because you'll notice right here, our 1 was our x value and it turned to its opposite. Now, the last rotation you have to do is a 360, and I hope that's common sense. If I take this particular triangle and I turn it 360 degrees, it should be right back where it started. Okay, so we're not really going to talk about that one much. So again, in review, a 90 degrees counterclockwise turn or a turn to the left, your x and your y trade places and your y turns to its opposite. A 180 degree counterclockwise turn or a clockwise turn, my x and my y stay in the same place, but they do both change signs. And a 270 degree counterclockwise or a 90 degree clockwise turn, okay, the y and the x will trade places and the x turns to its negative. Now, the thing I talked about in class the other day, a quick way to kind of remember this, was always think about your figure being in quadrant 1. And if I turn this object, okay, if I rotate this object counterclockwise over the y-axis, the y changes. If I rotate this object 90 degrees clockwise, then it rotates over the x-axis, so the x is what changes. So that's what I have to use in order to remember which one is going to change. So if I rotate clockwise, it rotates over the x changes. If I rotate counterclockwise, it rotates over the y, and the y value changes. And that's how we deal with rotations. Until the next video.